All right, gang. As promised, this video is going to give you a little brief introduction to R. Um, I don't use StatCrunch other than to teach STAT1150 and STAT1800. If I'm going to crunch data, uh, do stuff statistically, I'm going to use R. Uh, so I'm just going to give you a brief introduction. Okay, so if you just go to Google, for example, and just type R, just R, you'll see the R project for statistical computing. And you can go to download R. Again, it's free. Now, I'm not going to download R because I already have R downloaded on my machine. I don't want to change things. Next thing it'll ask you to do is to select a crayon mirror. I go to USA and I usually just choose something down here. They're all pretty stable today, so I don't think you're going to mess up with any of them. I choose Case Western. I taught a class for Case Western uh, a few years ago, graduate level class to some nursing students who are doing their PhDs. It's a quant methods course. That's why I chose it. Uh, I would probably choose Duke, but I'm a huge UK fan. I just can't do it. So if you choose, again, some crayon, go up here and download for your window, and just go through the process and download it, and pretty soon you'll have the icon on your desktop. All right. So let me just bring up R, show you what it looks like. A lot of students get intimidated by it first. There's no reason to. I'm not going to ask you to do. Well, I'm not going to ask you to do anything. This is just kind of a just an FYI if you're interested. All right, so let's go to, I think the previous video we looked at body data, right? So I am going to copy all of the data. It's a little tricky. And come all the way down to 300. And you know, it's probably, is there an export? Um, yeah, I can't see, I don't know much about StatCrunch. Um, yeah, okay. Well, let's just go through it as we would. So to copy this, just go Control C. For me, I have a Mac. And then what I'll do is I'll open up a Microsoft Excel spreadsheet and I will copy, or I'm sorry, paste the data. Now I'm going to get rid of a bunch of stuff I don't need. Or if I want to keep all this, you know, I could, but I don't want to because I don't. So I think before we looked at, for some reason I can't scroll over. All right, so systolic 128 was, what am I missing? 6643. All right, shoot. Systolic was 100, so it looks like this is the one I need. So I'll tell you what I'm going to do. I'm going to go in and insert a row here, and I'm going to put systolic, and then the 33.3 should be the BMI, right? Yeah. I'm just going to get rid of the rest of the stuff. I really don't care much about all that. All right, so I'm going to do a save as on my desktop, and I'm just going to call it data for no reason. And then I will come down to file format, and this is the important part. I want you to come down to what's called comma separated values.csv and save it. Now, it should be on your desktop. Mine is right here. So now what I'm going to do, I'm going to come in and just call my dataset data in R, and I'm going to do what's called read.csv, and I'm going to put a quotation there, and I'm going to drag this file right to the center. Now this has to be between the quotation. All right. Now, if you execute that by hitting enter and nothing happens, that means that that's good. Your data has been imported. I don't want to start anything yet because I still have to attach the data. And I'm going to go semicolon. I'm going to do a execute a command called head data. Now, what head data does is it allows me to look at the first 6 cases. And you can see for the first 6 cases, I have systolic and BMI. And then I can actually go length of either one of the variables, and I get my sample size, which in this case is 300, which we already knew. Now, the thing I like about this is the correlation code. The correlation output is much more sophisticated in R than it is StatCrunch, or at least as I can figure out StatCrunch. And again, I don't use StatCrunch, so there may be some things out there that I'm not aware of. But I can just run what's called a core test. Type in the variable names exactly, capitalization. You and I see systolic with a capital S and systolic with a lowercase s the same. R sees it as Venus and Mars, 2 completely different things. So make sure that your variable names are entered exactly like they are in the heading. And you get some cool stuff here. The output, you get your test statistic, negative 3.7352. You get your degrees of freedom, n minus 2. And you get your p-value, which is 0.002248. This leads me to believe that I didn't see well, and that there were only 3 zeros, and I thought there were 4. But the cool thing, it gives you the 95% confidence interval. And of course, it gives you the sample estimate, which is just the correlation coefficient. If you want to get crazy, we're going to get into pretty soon, we're going to get into model estimates and hypothesis testing for B1 and, beta 1 and beta 0. So what you could do here is you could run a linear model. And let's say we want to predict BMI from systolic. So in general, what happens here, I can communicate to you with a hashtag. That's the way R, I can put stuff in R and it knows it's not a code that needs to be executed. So the LM is in the form of Y tilde X. So we put our Y variable first and we put our X variable second. All right. So if we get our model, then we have the summary of our model, and you get all kinds of cool stuff. You get residual diagnostics, you get your B0, you get your standard error for the B0, you get your test statistic for the B0, and you get your probability or your p-value. Systolic, this would be the beta 1, right? So the estimate of beta 1. So B1 is 0.09, standard error, and the t-value and test statistic. I'm sorry, the p-value, the test statistic and the p-value are given there. And then you come down here, you get your R squared. Remember, R squared gives us the percentage of variance in Y that's explained by the regression on X, and gives you some cool stuff. Now, if you want the confidence intervals, just do confidence intervals of our model. That's not right. And you get your confidence intervals for beta 0. You get your confidence interval for beta 1. All right, so pretty cool stuff. Now, I do kind of like StatCrunch when we get into slopes and intercepts. But I just want to share this with you. I don't think you should run out and put on your resume, your Vita, that you are an expert in R by any stretch of the imagination. But I did want you to see uh, what you can do, and with R, and you can do, I can find the mean of BMI if I want, and I can find the standard deviation of BMI if I want. I can execute a box plot of BMI if I want. All right, running a little slow. Don't you love the spinning wheel? You can notice we get a lot of outliers. All right, I can run so we want to run a scatter plot. So I'll get a scatter plot, and I see kind of I see a little bit of a linear trend uh, with a positive trend. The relationship looks very low. Uh, so, and yeah, we can do all kinds of different things. All right, that's all I got. Take care.